the rodent screen, rodent 1010. After that, we usually webinar start at 5:35. We can give the 5 minutes for the supporter.
Okay, no worries. No worries.
Okay.
I take my video off then in this moment.
Yeah, I won't take too long. I do have to take the rest of the meeting on the road after this, but
do we do a recording is one question, and the second one is we already talked about it. If you can share the contacts.
Oh yes, I already recorded this one. I can send you a link, YouTube link after this.
Yeah, that's great. Yeah, give us a YouTube link, and so we can spread it further.
will do. Yeah, okay.
Dent still on.
Okay, let's start.
All right.
Good evening, dentist. Today we have a very special event, and we invite the try implant Mr. Helger Kast give out presentation talking about the implant I love. It's a very great implant, okay? And this is the moment, digital technique have the dramatic impact for our dentistry. Today, I think is a very exciting moment. Okay, and before that, I first introduced Pac Dent, Kevin Wu, gave us a presentation talking about the rodent 1010. Okay, the rider. Our NDPO, we thank you for the Pac Dent to support us for the past year and also this year. Okay, yeah. So that I give the time to the Kevin. Kevin, you can start.
Hi, everybody. Hope everybody is well. Dr. Zhang, thank you. And Holgar, thank you. Nice to meet you. Just wanted to touch base on our Titan and the material that Dr. Zhang and I have been working on. And we'll just go over this really quick. I'm with PacDent. I'm a senior product manager here. That's some of our team members here. I am at our corporate headquarters in Brea. We have over 600 employees worldwide. And we have just a whole host of products that I'm sure some of you guys use, including our rodent line, which we'll be talking about. So we do a lot of our manufacturing here, as well as our warehouse and sales and marketing. So everything is shipped out of California here. The three materials that we'll be focusing on will be the 2.0 sculpture, the Titan, and then our original sculpture. So original sculpture was released in 2019. We have since been able to reformulate to include both the Rodin as well as the Titan now. As you can see, we have all the other resins, including some of the denture base that we'll be having a course on soon. But predominantly the 3 restorative resins that we have been doing very well exponentially. So as you can see, a list of our printers that we are validated and compatible with. This is just a partial list. We have a full list on our website, Rodin-3D. Feel free to visit that website to see the growing list of printers. We have sprint rate compatibility as well now. I was sharing with Dr. Hogarth. So we can check that out as well. So really quick, original sculpture in the middle here. It was designed for definitive restoration, a permanent crown and bridge, right? It has a biaxial strength of 175 megapascal. It was our go-to resin, really groundbreaking resin that we were able to introduce over 50% ceramic filler. Okay, since then, we kept it as our aesthetic zone interior resin. We were able to introduce our Rodin Sculpture 2.0, which we fill with zirconia fillers now. So we thought this might be great more for your posterior single unit crowns, your 2-unit bridges. And now we were able to introduce the Titan to be your full arch. It will go into some of the properties on what the difference is for the. Before that though, Pactent was instrumental in able to redefine with the ADA what a permanent restoration crown to include ceramic crown that are printed now. So any of your crowns and permanent bridges that were printed can be reimbursed by the ADA with this insurance code including. So first of all, with the Sculpture 2.0, a typical bottle, we have 3 sizes. The largest size, 1.2 kilogram bottle, you're basically able to print upwards of 240 crowns, right? Which the economies are tremendous. It's testing over 200 megapascals, and the sculpture is over 60% filled with zirconia particles. So this bottle here typically has over 60% of zirconia. So it's a very strong material that we've been testing very well. Dr. Zhang has been gracious enough to print various appliances with this material, and it's been holding up very strongly. 60% contact filler, over 200 megapascal, and we've been testing the flexural modulus above all the rest of the other competitors that you can see on the market, including your Onyx Tough 2. The shade we're able to transfer over from our Sculpture 1, including all 16 Vita shades, including the 3 bleach guides. So the accuracy is very well there. Going back to the Sculpture 1, our original formulation, same kind of economies with the interior crowns and the posterior. We were able to print PMMAs with the Sculpture. It does test a little bit less since it's not zirconia fill of 175 megapascal, but still tests well over 6,500 megapascals in flexural modulus. And as you guys well know, your Buxter crowns from Glidewell, the price sheet recently has been over $300 for like a single unit crown sometimes, right? And Dr. Zhang, we are figuring out the economies, comes out to about $22 for a single unit crown, right? Takes 70 minutes. His assistant does some of the design work, right? Estimating about $20 for a printed crown versus a mill zirconia. Since Sculpture has been filled over 50%, it's very radio opaque. So versus all the other materials out in the market, it shows up in X-rays tremendously well. And then lastly, we'll get into the Titan a little bit. This is our formulation that we use for any of our long span restorations. Some of the arches that Dr. Hogarth is going to be going into today will work very well with the Titan. We're eager to see how this material will perform with tri implants. And we'll show some examples of implants today, but we'll love to see how this performed in Dr. Hogarth's hands. The flexural strength does decrease a little bit because we wanted to have that flexural modulus to be increased for longer span arches so that they don't break under flex. But they still work tremendously well, very tough, right? For your hybrid dentures, your all-in-X provisional arches, and your PMMAs as well. So the Titan really shines here in economy of scale. The Titan is maybe 2-3 unit bridge. You can print a full arch PMMA here, like an all-in-4, all-in-6, and as well as the split file designs for the denture teeth, along with the denture base. Some of the economies of scale, you can rewatch this. As you can now tell, you know, the zirconia arches, $6,000, $7,000, $8,000, which you can print in under $200 within an hour. And Dr. Zhang has a lot of examples of Titan being used to replace a lot of the mill products that we know. Again, the megapascal is a little bit lower compared to some of our sculpture material, but the increased flexibility is better than any of the tough twos sprint rate materials in market. Just showing real quick, the denture base we're able to use as well. And in the characterization category, being able to have that candy coated technique with all of our denture materials, along with the characterization of our teeth, has been really tremendous for Dr. Zhang and a lot of the dentists to characterize themselves. Very limited possibilities of the three materials combined, right? Full arch restorations, full premium dentures, any of your direct restorations or inlay onlays, class 1, 2, 3, 4, 5, 6, can all be printed now instead of having to use even composite. Dr. Ip in Australia was able to really tout the single central units here, as well as some of the dentures and even roundhouse bridges here with the Titan. This long of a span arch, not breaking without any metal coping is really impressive. And Dr. Ferguson was able to do all that. This is an article that we were able to publish with Dr. Zhang this past February on Dental Product Report. We were really proud, Dr. Zhang was really proud of this case. It's a 2-unit implant. We were able to print on custom abutments here. Being able to place the implants with the healing abutment and then being able to seat that very flawlessly. This was a bruxing patient and implant still working well, right? No fractures, no failures. So we're really proud that the printed restorations. And go read this article. It's on Dental Product Report of Dr. Zhang's philosophy. He can tell you more, but having the implant crown as a cushion for the impacts of the abutments and the implants, being able to break if it needs to minimize bone loss, minimize implant or abutment breakage. And again, the crown, if it does fracture, everything else is saved, right? And being able to print in the crown when the patient comes in for another $5, $10 is the idea here. So please let us know how we can help. And let Dr. Zhang know. I know he's a very great supporter. So thank you, everybody, for being here tonight.
Okay, thank you, Kevin, for the presentation. Okay, the exciting moment is coming. So we give the time to the Mr. Caster. He will bring to us a lot of the new stuff. Thank you.
Yeah.
Yes, it's your turn.
Thank you very much. And thank you very much for the invitation, Dr. Zhang. We met in Chicago, actually, in the midwinter meeting. And it's a pleasure to do this webinar with you and introduce you to the world's first full digital implant. We have a lot of world first patents on this implant. This is the first implant where you don't need an abutment anymore. It's an implant made for milling directly into the inner connection of the implant. So with our CAD/CAM milling solutions in our days, it needs just a change of the interface to be able to use those beautiful materials like zirconia directly into the implant. And also it offers us the possibility to use this beautiful material, like you just introduced us, this Titan material, to go with a temporary restoration directly into this inner connection. So we have the FDA, we have the CE mark, and I'm right now sitting in the USA in Florida. I'm from Switzerland, born and raised in Germany. I'm a dental technician, which is a quite big study in Germany, which is a long time ago. And I start my journey in the industry already in 2002 at Straumann, in the headquarters of Straumann. That was a great time because in this time there was no digital workflows, there was no zirconia actually really in the markets, no CAD/CAM. And especially no 3D printing in dentistry. And so we developed in that time the bone level system, the CrossFit connection in this time. And in that time I met also a lot of colleagues of mine in our days with the TRI company, where I'm working now since more than 9 years, or almost 9 years. We develop the future of implantology. That's what we're doing every day. And so I always introduce at the beginning a little bit of our company. This is let's say our different offices in Zurich. So we are 100% Swiss-based company. I always invite everybody, and at the end of my presentation I share my contacts, and I have also some special offers for you guys to introduce you to, especially for this evening. And so when anybody wants to travel to beautiful Switzerland, just give me a call and I will show you and introduce you on the right side to our production. That's our production site. We produce implants since more than 15 years, and we have with the matrix system where we are talking about today, we have a revolutionary change completely in the implantology, and I'm 100% sure that this is changing everything. And for example, we don't need abutments anymore, and I try to introduce you the next couple of almost an hour into the system. So this is more or less the philosophy which Tobias Richter, the founder of the company and also CEO of the company, an old Straumann member as well. And then also he was the former CEO of Implant Direct in Europe. Many years, and this is our philosophy. You see on the top side, Swiss quality. I already said we are based in Switzerland. We really produce implants with the quality aspect of Switzerland. Every day we perform a high performance, and you see myself, I'm still in the dress of big surgeries today here in Florida, and we just did a lot of full arches, fully digital, scanned and 3D printed temporaries. We will talk about that a little bit later in my presentation. We try to make your life always more simple. So simplicity is a really, really important part of our system. And I think it's already explained in elimination of abutments. The need of abutments makes your life so much more simple. And the Think Digital, that's the way to go. We have a digital world, and we in the dentistry have to go more digital every day to be successful and faster and more high quality that we could deliver the last 50 years of implantology. And so this is our promise we give you, and that's what we do every day. That's the production side directly in Zurich, 15 minutes away from the airport in Zurich. And so really, I really stay to my word. If you want to see this production site in Switzerland, just get my contact and contact me whenever you want. So let's go into the matrix implant from evolution to revolution. So on the left side, you see actually our implant system, which we are very successful over the last 15 years. We have an octagon connection. We have here a bone level implant. with a hexagon connection. And so all this was an evolution for us. But now we talk really on the right side of revolution. So no abutments, no cementation anymore, because cementation really, the cement is the reason why everybody the last, let's say 20, 15 years in the market changed from cement based screw retain to screw retained prosthetics. And so this is what we have in our days in the conventional workflows. We have an implant, we have an abutment, and in our days we have tie bases to compensate that problem that cementation was always too deep on a crown, and we had to cover up an angulated placed implant with a crown that we don't see the screw channel. And so this is the problem why implants get not placed always after the prosthetic procedure. So we need anyhow abutments to compensate the angulated placed implants. And in our days, we use tie bases to do the cementation outside of the patient's mouth. And then we deliver on a tie base an anyway cemented crown into the patient's mouth. And when you work with the matrix, it looks more or less like this. This is just like a rendering. So we can really design from the implant platform, we can design as dental technicians an emergence profile in any directions without any limits. And you can see also here on this picture, everybody knows that the tissue maybe goes a little bit goes a bit down. And so then in one moment after a few years, maybe the abutment shines through the tissue. We don't want that. And so with polished zirconia directly onto the implant, we have the best biologically best solution for for tissue and bone. And that's what we are doing. So again, here's a cementing, just like from a dental technician who has to cement a crown on a tie base, and he cleans that with his finger and delivers you a screw retained solution, which is just like a little bit a mismatch between this old world of old-fashioned implant connections, which are hexagon connections, deep Morse taper connections, and so on. They are not made for the new world of zirconia restoration. So that's why we have always to add these little tie bases in between. And when you see this picture on the right side, you can see this is causing chippings. This is causing loosening of crowns. The cement gets debonded, and that's the problems of tie bases in any system. So that's how we compensate. This is the new world zirconias, and that's the connection to our days implants. And what we did at TRI is we eliminate this need. And so I just want to show you some studies which are made, for example, here with Professor Hämmerle and Ronald Jung. Professor Dr. Ronald Jung from the University in Zurich, which are very close with us and helping us to develop here the matrix system. This is a study which is just brand new, actually. This is a zirconia crown, which you see here on top. This is a tie base, and this is the cement line, which is anyways there. And you know, inflammation of tissue and also bone loss is really a part of cement, which you cannot clean in the emergence profile, and so that's why we clean it outside as dental technicians. But anyways, this is how your implant prosthetic connection will look. That's the implant connection here. And after 5 years aging and hydropulse testing, hydropulse chewing forces simulation, you get the same crown with a lot of gaps here. And when we look a little bit more closer to this, this is what every patient has in the patient's mouth with a cemented crown on a tie base. This is a fact which we have, and that's why we at TRI, we were thinking a long time how we can give you a solution that we don't need these tie bases anymore, because actually this is, for example, what you can have in patient's mouth is just some random x-rays. So we always have a gap to the cement line, and also we have a gap from the abutment into the implant. And that's the first time where I want to share an X-ray of a matrix implant. You see, that's a special emergence profile. I'm going to talk about this emergence profile of the implant because it's a multi-level implant. It's not a tissue level, it's not a bone level, it's a multi-level implant, which we talking about here. And this is emergence profile, which we can design in nowadays, fully digitally designed, absolutely perfect in an anatomic ways, without any undercuts or anything with dirt pockets and something. That's what we can do with the matrix system. And this is 100% cement-free, as I already told you. And let's go a little bit more detailed into the implant system. That's the multi-level implant design. So from the outside, this is our rough surface. We have an one-to-one SLA surface, as you know it from the Straumann company. That's what we deliver on the surface part. And then we have this concave design here. And that means for you, it's not only, I'm not only want to talk in this time I have here about the connection. I will go into details of this connection, which makes the biggest difference. Also the outside design, the concave design, you see it even on my picture here. This concave design offers you a placement a little bit like submerged of this pink anodized meshing surface. And in nowadays, we know, those of you who know maybe the book from Professor Linkevicius, the book Zero Bone Loss Concept, there's a lot of described a description of anodized surfaces. So first of all, it's pink. It means it's very aesthetic. It adapts to the tissue. It has having a tissue color, but you have not to place this implant as a tissue level implant. You can place it in any height of this 1.8 color here. You can place it. You don't have to think, where is my hexagon or inner connection position. You just place the implant in the best aesthetic way and prosthetic way. You can place the implant. We have different diameters. You can see that here, and the with the same platform. Yeah, that's the platform. And from this platform on, and you can see already on this picture, it's a very round and smooth surface going into the inner connection. So if I have lateral forces on a 3D printed crown in 3D printed material in PMMA or in a final restoration milled, it's really smooth and round, and this gives us stability. If we don't go very deep in the connection, have a deep conical connection, which will break the zirconia. Many companies did try this way in the past years, and that didn't work out. And so we have one rotational lock. And when you look very close to this rotational lock, this is one part. It's peeking out in the middle, more or less, and that offers us the situation that the rotation in a single crown will be in a very thick zirconia area. And we have, as I said in the beginning, we have more than 6 patents in the whole design of the inner connection. Combined with this emergence profile, we absolutely are, from my point of view, ahead of times, because the connection here is absolutely ready for the digital world of implantology. And so let me go closer a little bit into this multi-level placement situation. So on the left side, you see our multi-level implants. That should be the bone line here, the yellow line, and that on the right side is our bone level implant. And so from placing this implant, because we as you know, we don't have an abutment, we can place it like tissue level style. But this is a multi-level style. This is possible. We can use the bone level matrix connection like on bone level. But this connection that like we are used to place a subcrystal implant, we can only do with this multi-level implant, because we don't want to have the connection deep below the bone. Okay, you can use a counter sink or a profile drill and get the bone away. But if you place our implant system in this way, you take immediately the compression out of the cortical bone. Here from drilling, you have the compression, but below the bone level, and this causes that the blood supply and life comes immediately to grow bone here And we even have some studies. I can't go too much into the studies of all, but you can watch them, and I share some links at the end of my presentation for all our scientific updates. But we can see in our implant system that this emergence profile changes also the stability of bone, combined with a polished zirconia in the connective tissue in this area. Polished zirconia is the best thing the tissue can touch, and so we have absolutely amazing and significantly better improved bone stability with this multi-level way of placing implants. So that's, by the way, Professor Dr. Linkevicius, and he did some testing of placing an implant like tissue level and placing it multi-level. It's very interesting. He posts these things sometimes on his Instagram. It's one of the most liked Instagram posts of Linkevicius. And so if you don't know the book or he wrote, it's called Zero Bone Loss Concept. I recommend this to everybody when you want to know more about, in our days, implant placements. Read this book. So we have two different platforms for the system. You see on the top, this is the platform 3.7. That's a more narrow platform. And as I already showed in my slide before, we have wider implants with 3.3 diameter, 3.7, 4.1, and 4.7 diameter. And you can choose the right platform for each implant position. Wherever you want to place your implant, we have the right platform to be right aesthetic. Ciao, you have questions? No. Okay. So then we have as I said, a bone level system and the multi-level system, and I will really focus on the multi-level design of our matrix implant. This is the different platforms, a wider one and a smaller one with different diameters. I think you all understood that so far. And by the way, if you have questions, we have at the end of my presentation enough time to answer all your questions. So why we do it, and why is it possible that TRI can offer you an implant system which is absolutely safe to place zirconia directly into the implant? This is the reason why. This is a random hexagon connection. You see, this is an old-fashioned, old world-fashioned hexagon connection, sharp corners. Here the hexagon connection, and that's a drill, and I just showed a video. That's a drill in any 5-ax milling machine, as everybody has it in our days in the praxis or in a laboratory. All those laboratories say we can mill all the connections, but we have a problem with a drilling tool. You can't cut corners, and so that's why we need something round, and this is what we do. This is a random drill out of any milling machine, and we have this round smooth, and this part is 20 degrees conical, so too less conical that the zirconia gets squeezed or anyhow gets any situation to get fractured, and too much conical to have any pump effect or something. So it's 20 degrees angulated. And when we mill a single crown, you see here, this part is only to finding the rotational lock, but because this part is peeking out, as I already mentioned, the rotational is inside the safety of a rotation. Not rotational, like a rotational lock is here in the middle, and that's why it's in the thick zirconia. So what I want to say with this picture, we thought a lot and we developed a long time to deliver this magical matrix implant to make this possible to mill the connection absolutely perfectly in any milling machine, actually. And so not talking about 3D printing. So what you can see here is again those two slides, and the connection, the matrix connection is only contains round and smooth surfaces, and that's why it is possible to mill this connection. Milling strategies are necessary. So we create not only the implant, we didn't develop only the implant, we also develop certain milling strategies. So to mill this connection in any milling machine, it's necessary that your laboratory gets certified by TRI to create, mill this connection with this necessary milling strategies. So you see here the milling path, which we implement in any CAM software. So these yellow lines are the path the drill is doing, circulating this connection, and also the inner connection of the screw channel plus the screw seat is milled by a certified milling strategy. and then we can get you a zirconia result, which is absolutely looking perfectly. So that's again, this is an STL file. And if you only mill an STL file on your milling machine, you will have just an STL based milled surface. And that's why we implement in each milling of a crown, of a full arch. And when we, by the way, when we mill a full arch, we don't mill this part, we only mill that part until here. So that means that we can have angulated implants placed up to 50 degrees in angulation. And anyways, we are able to screw retain without the use of an angulated abutment. We can screw retain it directly in the patient's mouth. That's what I just did with my dress here 3 hours ago in an upper and a lower jaw, fully digital. And so that's again, there's milling paths like in a simulation of a CAM software. So if you go really close into this path, we have here a 0.02 millimeter path, which the drill circulates to get you an absolutely great surface. And that's what I'm talking about. This is STL filed based surface, and this is milling strategies based, or TRI milling strategy based surface. And this is before sintering. So the whole thing shrinks up to 20% if you put it in the sinter oven. And that means the surface which is milled is even more smooth, and that looks like this. You can see here that smooth surface, which any milling machine which is certified by TRI, that's a must. Your laboratory must be certified to create those designs, those perfect surfaces. Or if you are a dentist, you can use our certified milling laboratories, which we have all around the globe already, and they can produce you this quality into a milled crown. If we look in a square cut, you know, this is the implant, and that's the crown, that's the screw. Also, the third part is it's the implant connection, it's the milling strategies, and the third part I want to talk about is the screws. We have special screws designed that we can be absolutely without any screw loosening, because the screws are much longer than any other screw. I don't know if you use for full arches the Rosen screw or whatever. There are very short screws. You can only hand tighten them on your multi-unit abutments. If you use for full arches the matrix implant system, we have very long screws, and I will share this in the next picture. But you see here the screw, the implant, the crown and the connection. Another thing you can see here, there's almost no air in between. There's no gaps in between the connection, the screw, and the implant. And that makes it so sealing up. And then we have here a very cylindrical part, which makes the thing absolutely stable for zirconia crowns. Again, a picture from the not sintered part, and this is the sintered connection just milled in a certified milling machine. So that's just some pictures, and I told you I want to talk about the different screws, because that's also a part of the developing of the matrix system. We need, for example, for angulated screws, we need a special screw head. So that would be our angulated screw. We have longer and short screws. You see that on the right side, you see a little bit shorter screw. This I would only take because we don't have an abutment. So you compensate with all the prosthetic, you compensate the height of the implant. So when you have an abutment, you take the abutment higher up. So you are higher in the tissue, but we don't have that. So we need longer screws for deeper placed implants or higher, thicker tissues. And that's why. And when you see this, basically the main screw, which we always use, this screw is really long. And long screws means if you force, and we use here 35 Newton centimeter to screw retain a final restoration, and the 35 Newton centimeter will be stretched in a long way. You know, like the zirconia has a bit like a spring. You know, you tie it up, and 35 Newton will stretch a little bit the zirconia, the titanium screw, and that means when it's stretched, it never can get a screw loosening. That's just sure. If you have a short screw, you first of all, you can't get so much torque on it, and the stretching is not as much. And so after chewing forces, you will get screw loosening. We don't have screw loosening with the matrix implant system so far. 30 degrees angulation is also possible. So we are able with milling machines and with 3D printing, it's anyways no problem. We can mill in 3D print in any direction, but with 3D print, with milling machines, we can mill up to 30 degrees angulation. So when you place your implants in a static zone, a little bit tilt, and the screw channel would just look out of the buccal side, we can angulate the screw channel 30 degrees out of the aesthetic zone, and your screw hole will come in the lingual side out of your thing. How can we do that? We developed also so-called T-drills. You see here a T-drill, which you can add into your milling machines, and the T-drill has a very narrow shaft here, and you go inside with the T-drill, and then you see this video here on the right side is a simul animation here. You see we do an eccentric movement to mill this screw seat here in this part, which is very important that the screw seat is milled in 90 degrees and clean milled. That's how we do the angulation, that we can be in aesthetic zones also with a compensation of an abutment, okay? So, and then that's just like, and then from the top, we mill the angulation with another drill. We come from the top in this direction, and that's how we are able to mill up to 30 degrees angulated restorations. Yeah, this is just again the T-drill, for example, in the Amann-Gierbach system. So if you have an open system, like you have any CAD/CAM milling machine with working with a CAM software like Hyperdent or Millbox, we have to implement those milling strategies which are special into your system. If you have a closed system like Amann-Gierbach, VHF, or Circunsan, those milling strategies are already implemented by the provider of Amann-Gierbach, Circunsan, or any other closed system. And so this is offering you the possibility to mill with those closed system already the perfect connection of the matrix implant. Again, this is just like some pictures that you see the connection, how tight this is. And another thing which you see here on this picture very nicely, because I always get the question, hey, do you have screw breakages? No, we never have screw breakages because we eliminate an abutment. So that means we have much more space in the implant itself to create a much longer screw. As I already said, that's, by the way, the short screw. The longer screw will be here. That's the shorter screw. And we have a thick zirconia area, which makes this stable enough. And the width of the screw itself is very wide because there's no abutment. There's nothing. So we can have like a bolt, which fixes the implant into the prosthetic into the implant. So this is actually the certification program. So for those of you who are interested to get your lab certified or want to see more and being certified dentists, we can. It's not a must to use the system as a dentist being certified, but you can learn here a lot more. There's like little QR codes to get this certification, or you just take a picture and go on the website www.tri-academy.swiss, and you can go into a certification program. This is for free if you are interested. And let's continue with Professor Ronny Jung. I already mentioned him before. He is the actually the boss of the university in Zurich, and he is the president of the EAO group in Europe, and he is one of the most famous professors in these days, and I think his journey just starts. And he once said, like 3 years ago, the future of implants restoration, a new era of personalized dentistry. That's what he meant for our matrix implant, and I want to share with you the first case now. So what we can do, we can not only mill immediate in a chairside situation, we can also 3D print. And we just had a presentation at the beginning of different 3D printing materials. And 3D printing materials offer us a chairside solution. And with a matrix system, you don't have to add an abutment. You don't have to add a tie base. So you can place at 3 o'clock in the afternoon, as Ronny Jung did it here in this case, you can place a matrix implant, which looks more or less like this. And after you place the implants, you just add a scan body and you do a scan to know where this rotational lock is placed. And then this scan body gives us the position of the implant, as everybody knows, and we can mill. In this time, we did mill a crown, but you can also 3D print a crown in between 15 to 20 minutes. Those printers get always faster. The materials, as we heard in the beginning of the presentation, get much better. And so you can 3D print a temporary crown absolutely aesthetically with a perfect emergence profile to shape your tissue from the first moment on. You can shape the tissue in an emergence profile and being totally aesthetic. You can send out your patient with a temporary crown, absolutely aesthetic, a little bit out of occlusion in between less than an hour in our days. So this is the temporary crown. Just like at 4:30, the temporary crown is delivered out of occlusion with a nice emergence profile, with a biocompatible material, either 3D printed or milled in PMMA. And that's after 90 minutes. We say in these days, because this case is already like 3 years ago or 4 years ago, I think I share even the X-ray of it. So that's what you can do. So it's an absolutely great chairside system. So you don't need to add all the time a dental technician only for the design service. You design the crown, you add it on your 3D printer, and you print out a crown and get it in the patient's mouth. And the next great thing is that you can do, after 3 months, just a copy of the emergence profile, add a little bit of occlusion, and mill this zirconia in a zirconia as a final restoration with polished zirconia in the emergence profile. And then the patient comes to your office and you just exchange the temporary to the final restoration without the need of a new impression. So that saves you a lot of time, because in all other systems, you have to take the temporary out, you take a new impression, you wait until the dental technician gives you a final restoration. In that time, you have to add the healing color or whatever into this connection again. And here you can just copy paste this emergence profile down to the crown, down to the implant connection, and then you are ready to exchange that. That's what we did in this case. And you see here this perfect adaptation of tissue, and also the perfect bone growing also into this concave design of the implant with an absolutely great polished zirconia emergence profile. And there's no cementation which can destroy or disturb the environment of your tissue. And so that was a single graft. That's the 3 years follow-up I just talked about. And you see the bone is really stable, even in this concave design. On this side, you can see it even better. So the bone grows to these anodized surfaces. And when you see again here, after 3 years, we get results back from customers which tell us how beautiful the tissue starts to grow to this zirconia without cementation. So also when you buy an implant, and then now we go more into the 3D printing world actually a little bit. And so when you buy the implants, we say we offer you with each implant bought implant, we offer you 8 different apps. And I would like to take the time to talk about these 3 apps here, starting with the Scan and Smile app. So in our days, we can offer you, like in this video showed very quickly, you place the implant, you have the situation, you extract the teeth, you place the implant, and you get the scan body, you design your crown, and you 3D print the temporary. And I want to show you how fast this goes. So let me show you the next case. This is just placing an implant in an extraction minimal invasive placement. And you see how beautiful this pink color adapts here into this environment. And before you start even thinking about bone grafting or anything, you add the scan body, you do a scan of the position of the implant, and we can provide you as TRI, we can provide you in between 20 minutes. We provide you an STL file, which you can put on your 3D printer. This is this STL file. and we design you the perfect crown, or we can also design you only an individual healing color, not as a crown, just like really as a healing color. But in this moment, you design in the first day the emergence profile. In this case, which we just see with the minimal invasive approach, we can even copy the emergence profile of the just extracted teeth. And so it's a one-to-one duplication of what was just in the patient's mouth. So there's not even a long healing time of tissue or anything. The tissue just adapts to this connection. We can do that also with chairside milling machines. That's the Amann-Gierbach chairside, the Amann-Gierbach chairside milling machine. With high-speed sintering, you are able in 50 minutes to have even, as you can see it here, a zirconia crown milled and sintered in 50 minutes. Chairside, you can go up to 3-unit bridges in our days with a speed sintering process. But in this case, we did a 3D printing. So at 10 o'clock, it looks like that. And on the right side, at 11 o'clock, we had a patient smiling perfectly with a crown. 3D printed, maybe for material wise, maybe for $1-2. With our design service, you pay $20 and you have a perfect design for a single crown, which you can 3D print. And this is after 1 month, a 3D printed crown. You can see how the tissue, even on a 3D printed crown, is already adapting. And that's a 1-year follow-up with the zirconia crown. You can see here the zirconia crown. And here, I think, again, look how the bone grows even to the zirconia here. This is just like possible because we have no anywhere any disturbing cementation line. That's what is possible, as I said. And again, here I put a 1 month temporary 3D printed temporary on the here on the right side. Just watch the papillas, how the papillas get longer after 1 year, and that's again only with polished zirconia and tissue possible. Let's talk about the next app which we developed. So with this, we want to make your life more simple. So we developed so-called digital healing colors. Those digital healing colors are just like different shapes, emergence profile shapes. And so everybody who places implants, every company offers you round healing colors, but not emergence profile healing colors. And what we give you, and we give you this for free, we give you different shapes of healing color STL files. And so you can go and mill them in zirconia if you want, or you can 3D print them, as you can see it here, just 3D printed emergence profiles, and you can choose, because we offer you, that's for example, for single crowns, different shapes of emergence profiles. When you don't have a chairside 3D printer, you just let your laboratory 3D print these. We have different shapes for different situations. For full arches, we have different emergence profiles. We print them, and in the surgery, you just break those healing colors off. You place them, and your emergence profile get already designed after 3D printing. It looks like this. This is a glassy clear material, because you can also do a white material, and you have emergence profile to manage your gingiva from day one. You can do that in polished zirconia, as we already said. Polished zirconia is really nice for the tissue. And the next step I want to talk about goes more into the full arch restoration. So everybody knows, with full arch restorations, and in our days, intraoral scanning, we have most of the time a certain problem that the matching of the intraoral scan pictures doesn't line up perfectly, and that's why we have mismatches of full arch printed or milled full arch restorations. And that's why we created and developed a very, very nice product, and that's called the Scan Bridge. So the Scan Bridge is created because of this reason. So when we have a full arch, especially the lower jaw, there's very smooth surface. There's no reference points for a scanner, which takes, you see this square here, the scanner does several pictures circulating the full arch, and these pictures have to get matched. These pictures have to get matched. And here, this matching can be not really done very nicely, accurately, because the matching has no reference points on a smooth surface, and that gives you a bad fitting of your restoration. And that's why we created, or companies created, photogeometry. And photogrammetry is something very expensive. So if you want to use photogrammetry or full arches, you have to pay $50,000, $60,000 to be able to have accurate produced full arch prosthetics. And what we created for you is this is our scan bodies. They are by the way also open tray impressions pose. And that's why they have these little undercuts. And what we created is here the Swiss Matterhorn. For those of you who know the Switzerland, that's the design of the Swiss Matterhorn, to remember you that we are from Switzerland. And you can click those scan bridges just to your scan body. And then you capture this part for the positioning of the implant, and you capture and you have reference points. Even this part is bloody. It's just like even an open jaw, a flap raised jaw. You can add those scan bodies and you click those 3D printed scan bridges towards, and you connect them to the neighbor scan body. And then you have reference points in a clean environment with no blood. And this gives you an absolutely accurate scan without the need of any photogrammetry. This is the STL file. You just download the STL file from our homepage, from our website. There's angulated ones for the tilt implants in a full arch and all on X situation. And you can click with this little click here. You can click it to our impression post, and then you are ready to have an absolutely perfect scan. You see here again different angulations, different designs and different shapes to click to your scan body. And so this is how we go in a surgery. We just like 3D printed those files. That costs nothing. Again, you can get offered this file from our website. You just download the file and then you are ready. So in this case, you have a small gap here. So this is captured by the nowadays better 3D so intraoral scanners. You can scan this very perfectly in between longer distances. You just click and fix the whole thing with a little drop of light hardening light cure material. You fix the scan bridge, and then you are able to scan all around the full arch. And as you can see it here in a chair side production, this is a case we did upper jaw, lower jaw. In the upper jaw 6 implants, lower jaw 4 implants, and then we can scan this after, even if a flap raised situation, we scan above here in less than 2 minutes. We scan that. We have the position of the implant place, and you can see it here on the screenshot of the actually file, that everything is really clean. And through to these reference points, the little Swiss Matterhorn in between, we are able to have an absolutely accurate scan, even in full arches. And the patient goes out after 3 hours with an upper jaw, lower jaw, 3D printed, temporary in a nice way. And that's possible only with the scan bridge or with a photogrammetry situation. So we offer you 2 different ways of scanning full arches. We have the photogrammetry situation with PIC dental or all the other systems. We are able to deliver scan flags to our system, but we have also the matrix scan bridge, which costs you nothing, as I already said, and you just add those scan bridges. I just come out of a whole day a full arch surgery, and we deliver the patient in the evening or in the afternoon, upper jaw, lower jaw, just screw retained the 3D printed temporaries, and we could send the patient out with a perfect passive fit. So yeah, this is a photogrammetry case that you just see how we do that with photogrammetry. So we place the implants. You can see here on this picture, slightly submerged placements with this multi-level style. The platform should be not below the bone level. But then you are able to design in an emergence profile very aesthetically. You add the scan flags or the scan flags, and then you do your scanning. And you can also, and that's the point, when you do photogrammetry, you anyways must do a tissue scan. And if you want to do a tissue scan with the matrix system, with those scan bridges, as you can see it here on that side, the scan bridge is above the tissue. So that means you can do the scan bridge scan, and below you have enough information for a dental technician to have the absolutely perfect tissue shape. And so you don't waste your time with 2, 3 different scans. You just do one scan with the connected scan bridge, and after you are able, you put healing colors for until the time of the delivery of the upper and lower jaw, or this is not only an upper jaw in this case, and the patient will be happy after 3-4 hours work without the use of any choosing the right abutment and so on. You don't think about where to place the implants, because we can 3D print with angulated screw channel, as I said, and you can have tilt implants up to 50 degrees, and the thing will anyways fit directly into the implant position. Another thing you see here on this little picture, and it's a little bit but you see the thick wall of the placement into the implant. So it's much thicker wall on in comparing to a tie-base based temporary. A tie-base has sorry, not a tie-base based temporary, a multi-level on a multi-abutment. On a multi-abutment, it's always a multi-abutment, is always like a pyramid and has a very small frame where we 3D print or mill zirconia on top of it, and then we have a very little small Rosen screw or whatever screw. It's a very small screw, and here we go with our long screws, a thick screw with a thick wall circulating onto. You see the implant here on my picture. I don't know if you see my face here. It's a very thick wall where you base your full arch restoration on, and that's why we have also much less breakages around the multi-level screw retained temporaries. Yeah, so no abutment, no cement, no limits. We have the possibility to angulate up to 50 degrees in between the implants. We don't need those tie bases anymore, so you have less components in your office. We have different screws, as I already mentioned, for different materials and different situations. So that's why it's important to understand this thing. This is the future of the implantology. I promise you this. And if you want to understand how you will place implants in the future, how you will restore, you have to go and do this certification program for free. We have interfaces for crowns, which you go into the interconnection, and for bridge, we don't mill this inner connection and the rotational index. We just mill into the inner connection and have the possibility of angulations. We can angulate screw channels up to 30 degrees. And so we have no limits and no cementation. That's quickly a video before the next case. So yeah, that's just, again, we can place this implant in a multi-level style. As you can see here, we can angulate the implants in any direction. We are completely free in placing the implants how we want to do that. And we can fit a full arch restoration very nicely on the implants or in the implants, and we can angulate those screw channels. That's not true. We have 30 degrees in our days. That's always what I say, you know, that you just saw there was 20 degrees written, but our implant connection is ready for the future. We are, with this implant connection, ahead of times. So milling machines get better, so we can mill more than 60 degrees angulation between implants. We can 3D print better, and so the machines have to follow our connection. That's what we do here. And so that's just a case. That's a one full arch case, and I can tell you this is the very first full arch case made in the biggest European clinic. The clinic is called Dentaprime. It's a clinic. They do 50,000 matrix TRI implants in a year. And that's the first matrix full arch case, which we did almost 4 years now ago. And I want to share this with you. That was before we had the scan bridge scanning. But anyways, those guys in the at Dentaprime in Bulgaria, as I said, only in Bulgaria, 50,000 implants. They want to go. They are the pioneers of full arch restorations, fully digital, and they are going with us this journey. And the case started like this at 9 o'clock in the morning. In these days, we placed the bone level matrix implants. In our days, we only place those multi-level matrix implants, because we can here be, when a tilt implant, we can be anyways out of the bone. And so, but in this case, we placed 4 in the lower jaw and 5 in the upper jaw. And so this is the scans. which we created, and after scanning, and that's also the great thing of digital dentistry, you would have, when you go with a digital smile design, you design everything before you start even placing the implants. So you need to provide to your designer an upper jaw scan, a lower jaw scan, a bite. And this is what is already enough. It's much better when you have a CBCT scan, so the designer can match everything and can design you the perfect. He can widen the jaw a little bit. He can raise the bite, and he can design you the perfect temporary. Yeah. And then when you place the implants and then you send him the scan of your positioned implants, he just has to match the design for which he did maybe 2 weeks before the implant are placed. He can only match that, and it takes him maybe 30 to 30 minutes to 1 hour to send you an STL file, which you can 3D print or mill out of your chairside milling machine. That was the very first, that was milled situation. That was the very first full arch we delivered completely digital. No silicon involved, no nothing. We did a full digital workflow with a very strong angulation here. And we delivered the upper jaw and lower jaw after 6 hours with DentaPrime. In this time, in our days, there's several big clinics which love this situation, that they had not to think about abutment placement. They just can go and concentrate on the surgical part, and then having a nice design scan, and then we can do this workflow in a very fast way. That's after 4 months in temporary times. This is the patient after, I think, 7 months. We delivered the upper jaw zirconia and the lower jaw zirconia. This is, I think, now around 4 years ago with this system. And the patient is, this is 3.5 years follow-up that I get like half a year ago. I get this is the 3.5 years follow-up. And again, we don't have any disturbance. We have just like beautiful bone on a polished base of zirconia. So the environment is absolutely perfect for having a stable bone over the next 20-25 years in a full arch restoration. Yeah, that's just a picture because I'm a dental technician, how these things fit even on a plaster model. In these days, we did plaster models. In our days, we are so safe with our system that we not even use plaster models anymore. And so we have an absolutely perfect passive fit before we deliver this crown, this full arch into the patient's mouth. This is something I would like you to take out your pictures, your cameras, and then there's a QR code. This is a casebook and catalogs. You have all the information of the matrix system. We have a lot of scientifically studies. We will have in 2 minutes, when I finish my presentation, the time to discuss. Yeah, I can't go too much into the scientific updates, but yeah, maybe we have still a little bit of time. So take just a picture of this QR code for more informations. There's also a next QR code, which is when you are interested in more cases and see how this changed your way of placing implants, how this changed of your way of tissue management with this matrix system. You have here a casebook which we work all the time. All the cases you see, we have follow-ups now up to 4 years with this system. In this casebook, you can follow this casebook. It's a virtual casebook, and you can see really big cases done in the last years, in the last 5 years actually, and 4 years prosthetical follow-ups. So you can again do a screenshot here. And we have also a special offer for you guys. So all of you who are still here and waiting, here in the US, and I think the main people here sitting in this presentation, they are from the US. And so we have a special offer. If you are interested in trying the system, I can offer you some different packages right now. And because we have today this possibility, we give you 5 implants extra. If you would decide to try it, we give you 5 implants extra. And so that's the first offer. This is an offer for $12,250 with 25 implants. And what we do, we have a design service here. And the design service designs you the final restoration. We design you also the temporary restoration. So when you have a 3D printer in your office, you can just go tomorrow, place those implants, and we make sure in this offer, you have the screws for your crowns, for your temporary crowns, for your healing colors, and also the same screw for your final restoration, 25 screws, 25 implants, the scan bodies 15 times, and the surgical kit. Plus, as I just said, if you contact us tonight, yeah, you will have 30 implants for this price with final restorations. The next offer I want to make to you is an offer with 25 matrix implants with even one full arch included, and then you will maybe want to work with your own designer, or you can anyways get back to us for 6,800 euros. It includes again the surgical kit. This is an absolutely cheap starter price to start with the system, to try the system. You can go, I go here in the US a lot of times in clinics which they want to go only full arches, and others they just have a chairside stuff working on with single crowns in an hour. You can do that with our design service. You are ready for this. This is the contact where you have to write actually an email tonight, customer support at tri-implants.com. If you are interested in this bundle plus 5 implants, please write there tonight, or call on Monday our telephone number here to get these bundles anyways gone. And now it's time for your questions.
Okay, thank you, Helge. It's a wonderful presentation. It's also is eye-opening. Okay, here we have some question on the chat. Okay, let me read the. You can go to the chat. The first one.
What was the Instagram account? Thanks. The Instagram account for TRI is TRI underline. Sorry, I think I share it. I share it here. The Instagram. I will do that later at the end. Can you use a resin crown as a permanent crown over TRI implant? So yes, we can slowly do that. We just had in the beginning this beautiful new material, Titan, which you can use because it's stable enough. It has like more than 200 megapascals, so you can do final restorations. Also, the Onyx Tough from Sprint Ray is offering this with these stronger materials, and it depends on the materials. So you need to have a higher strong material to do that. We do that, we start to do that, and everybody knows who knows a little bit of 3D printing. We are in the beginning, and the materials will change. I think the next half year, we will get more and more materials. Our connection is ready to do finals for sure. Yes. Do you prefer milled zirconia as a permanent restoration over TRI implants? I mean, yes, I prefer still zirconia. And by the way, I only talked about zirconia. You can also mill a titanium bar, or you can mill titanium abutments if you want and cement something above it. It's just like you can, that's what you have to understand with this connection. You can mill when you are certified with these strategies, you can mill everything you want to mill. And so from my side, it depends what patients you have. Sometimes a 3D printed, not a little bit flexible material with a PMMA and zirconia included is better because it's softer. And sometimes it's maybe better to have really a highly polished zirconia as a final restoration. So I can't really say what I prefer, but in nowadays for really high aesthetics, I still prefer cutback actually, which you do not too much in the US, but we from Europe, we try to really individualize stuff. So we do cutbacks on our monolithic crown and veneer it a little bit to have a high aesthetic, and therefore I think it's zirconia. This implant is approved in Canada or not? The Canadian have a special thing, and we are not approved yet in Canada. We are working on this. We have the FDA for the US and the rest which is working under the FDA, and we have the CE. So we are almost everywhere available, but Canada is still not available. We are working on it. For full arch case, can you reduce less bone because more space within abutment with matrix implant? That's a good question. You know, reducing bone is why, because we want to have the smile line perfect. And so what I can say for this is you have a very, very great feedback or feature on the matrix, because the matrix implant is on the bone line, and even the tissue comes a little bit reduced tissue. You only have white, so you never show up any abutments after 2 years, 3 years of a full arch. Some people, some dentists, especially when the bone is not cutted enough, they come and have a gray shining abutment. We are white until the implant. And so yes and no, you can reduce. The reduction from bone is really based on the smile line. And so we have to work with this. But yes, we are going down all the way in zirconia. And that's why maybe I can say, yes, you can reduce less bone. For full arch case, can you? Okay. Is your smallest implant 3.3 millimeter? Yes. Do you use the 3.7 millimeter color for 3.3 level implants? We have the platform 3.7, and the 3.7 platform, we have the implant diameter 3.3, 3.7, and 4.1. The platform 4.5, we offer you in 3.7 diameter, 4.1, and 4.7. So, so your question was 3.3. We have 3.3 implants with 3.7, which I love as an implant. Just in this case I did today, there was a lower jaw, very narrow bone, and it replaced the 3.3 in the implant body. And we had a platform 3.7. This is absolutely perfect. Kevin, can you use ISQ with TRI? If implant is not stable, can you bury under gum or flap, or is collar too tall? I don't get. We have ISQ, yes. You place the matrix implant always under the gum, or just on top of the bone level, and so I think I don't know if this answers your question. So far I don't see more questions. What Leil's asking, what's the maximum angulation for the angulated screw channel? It is 30 degrees in the situation of single posterior implant crown. It is 30 degrees. So your implant can be placed in 30 degrees, and you can be able to angulate the screw channel up to 30 degrees. And you know, if you place your implants, and I would never recommend, when you really place and you think also on the guy, I'm a dental technician. If you think about prosthetics, then you should not place an implant in the aesthetic zone more than 30 degrees anyways. But if it's necessary due to the bone or whatever, you could always place the implants more than 40 degrees or 30 degrees. And then you design a mesio structure, mill it in zirconia, have polished zirconia in the emergence profile, and anyway cement to cover the screw channel on tissue level. You know, the cement line, which is cement the ground then to cover the, so we are just like as any other system. So then you create your own mesio structure, or let's say you create an individual abutment for this situation when the aesthetic is too much tilt. Okay. So,
Harker, another question. Do you answer do you have the bone meal in your surgical kits when you use the bone marrow implant?
If you do what in the surgical kit?
You do have the bone meal, you know, you cut the bone, the meat. You see that can you repeat the answer to the bone meal?
Bone meal. I don't know why. We
What's
don't
mean
have
the bone meal? Doctor, can you?
I don't know what you mean with bone meal. I answer Lai again. We are in Texas. Yes, we have like here in the in US we have a sales team, And we have also provider distributors who distribute our system. And therefore, if you are more interested, please, and I just switch again, sorry, I switch again to this customer support where I, as I say, like the offer I just told you, 25 implants, plus 5 for today. Just write our customer support or call this number to get more information on Monday. They don't work on the weekends. But this is what I can offer you. The bone mill means bone profile. Okay, yeah, the bone profile drill. Yes, we just about we didn't have the profile drill, but we have just developed one, and it's not available yet because of FDA reasons in the US, but we will have it quite soon also for these reasons. When you are tilt and you want to cut a little bit bone, but I can tell you a tip: when you place full arches and you have a very tilt implant and you want to go with the, at the distal side, the implant maybe goes under the bone line. You think about it before you place the implant. You just take a round drill and cut a little bit the distal side before you place the implants, and the implant will be perfectly outside the bone. Do you see any fractures at the connection of the zirconium? No, we don't. This is what I try to explain with this thickness and so on. Sure, we did a lot of tests, and we don't have the time now to go more into details. We can maybe do that in the next webinar or something, but you can go, and I share this here on the TRI.Swiss site. There's all the scientific updates. There's a lot of studies done that we could reach the FDA and all those things. And so it's clear, if you force the implant with chewing forces more than, I think, 120 kilos, so 1,200 megapascal, then it maybe break the zirconia, but it breaks it always on the screw head level. That means you can remove the screw and you take out the rest part, which is not in the inner connection, easily. With any other system which goes into the inner connection of old-fashioned implant connections, when the breakage, the zirconia breaks, the zirconia stuck in the implant. That will never happen in the matrix system. Is there a micro pump between crown and implants? That's a good question. I didn't remember the English word of micro pump, so that's what I tried to explain you before. There's a 20 degrees conical area. It's not a flat surface. So we have 20 degrees. So with lateral forces and a screw which is very cylindrical into the implant itself, we have a very, very stable situation there. And 20 degrees conical means you can't pump it up. If it would be a flat connection, you can lift it up. And the next thing which you maybe remember in my presentation here, we have very, very little air and gap between the crown and the implant and the screw. So there is not a lot of space, as you know that from our old-fashioned abutment-based implants. Okay, what's the feature of drills for the osteotomy? How you mean that? Sorry, the feature. I mean, you can take Versa drills, for example. We have in our surgical kit a soft bone drill and a dense bone drill, so you can play with the primer stability. So yeah, the surgical protocol I did not implement in the presentation too much. Okay, let me maybe share. No, I don't share. So I think there's not coming more questions. You're welcome.
I have one question.
Yeah. Hi.
Hi. When do you use your implant level, bone level implants? The ones without the pink color.
When we do the bone level implant, I mean, this is a very good question. I mean, we have created this bone level implant, and I can tell you in the history of TRI, we have 15 years, we have a bone level system, which has nothing to do with the matrix of a hexagon connection in our portfolio. And we have a classical tissue level implant in our portfolio. In the last 15 years in this performance line, we have the bone level cells are 95% and 5% tissue level implants. And here with this system, everybody understands that this is a multi-level implant with this concave design. And now we sell 90% multi-level implants and only 10% bone level implants, because you can place these multi-level implants also on bone level as you can place the bone level implant. It's just like I would use the bone level connection when you have very narrow tissue in molar region and you want to be really, really close to the bone, that you can create anyways an emergence profile, but you can do actually the same thing with the multi-level implant. And as I said, simplicity is very important for us. And maybe in 5 to 10 years, because it's a changing of philosophy, maybe in 5 to 10 years, we not even need this bone level implant anymore.
Okay. So have you seen the pink color? Have you seen the zest locators? They have the pink color too.
Yeah.
So the color of your pink color compared to their locator, is it similar color or different or lighter, more close to
we made for this pink color. We made for this pink color also a study with the university in Zurich until we found out exactly what pink anodizing we want to have. This is not easy to get this pink color on an implant. On an abutment, it's easy because we have also the surface treatment below. And so it's really, that's why we never get copied more or less with this pink anodized surface here. But so we made it a study, and you can also watch this study on our website. And we put pink color, different shades, and even gold colored shades, titanium plates under 1 millimeter thick pig tissue, and layered it, and we measured the shining of the tissue, the discolorization of the tissue with and we found out that this pink anodization is exactly what we want to have. And to create this anodizing process is really a tricky process to create, and it's not so easy, and it's quite cost expensive to do this pink anodizing. But again, when a CEST has that's in an abutment level, and they have those abutments more or less shining out of the mouth. So you do the CEST connection there 5 times on it, and I'm quite sure the anodization is going away and it's gray again. When you have this in the tissue, it will never go away. But if it's on the top and you remove your bowl attachment, then it will get off after a few years maybe.
Okay. And your smallest implant is 3.2 or 2.75?
The implant diameter smallest is 3.3 with a platform 3.6.
Yeah. So your smallest implant 3.3, but the smallest platform 2.75.
Yeah,
so
right.
Are you developing a smaller platform color for the small implant?
I think there's no need for a smaller platform. First of all, there's we don't have an abutment. So if you have a smaller platform in an implant, you have always to add a tie base on it, and the tie base will be also 3.7 or 4.5 wide. Because only the implant itself. And what you have here, you don't have a tie base below or any abutment below. That means you can create zirconia straight up, straight up. And sometimes in scissor, lower jaw in scissors, sometimes you have to create in some implant system the platform of the tie base or of the multi-unit abutments is wider than the teeth you want to design. So the teeth looks like this at the end. And with 3.7 straight up, you can create every narrow space of implant crown. Okay, I think.
Yeah, I have one more question for the platform, the 3.7 and the 4.4. The central screw is the same or the different? The diameter, I mean.
The what is the same?
the central screw, the diameter.
The central screw, yeah, the screws are always the same. You have a different scan body for different platforms, but the prosthetic screw is for platform 4.5, the same as for 3.7. Our product catalog, I didn't share that now in the presentation, it's a DIN I5 product catalog. The first side shows you all the implants. The second is a double side with all the prosthetic components you need. That's the product catalog. So it's not like a catalog like this thick. It's just like a very narrow product catalog with products which you need to use our system.
Okay, thank you very much, Helge. I think you must be tired. You work.
Yes, I'm quite tired, and I hope. Yeah, I had a tough week. Yeah, and we did like from Wednesday to Friday. We did in this clinic I have been. We did I think 8 or 9 full arches, and in two surgical rooms. I jumped from surgical room to surgical room, and everything fully digital. So we are working and showing the matrix. And again, it's just like want to tell you, hey, you have an offer there. These 2 offers are just like this one and this one. We add 5 implants, so just contact customer support, and you have the possibility to try the system for a very low price, and you have the surgical kit for any other new orders. Okay.
Okay, so doctors take this.
I wanted to say thank you as well, and here's also my contact. You can QR code it if you have questions more afterwards. You can always contact me directly. So I wish everybody a beautiful weekend, and for me it's time to hit a beer.
Okay, thank you, Helge. Thank you
Thank
so much.
Thank
Bye.
you.
Have a
Good night.
Bye.
Okay, we are the webinar stop here, and I just next Friday we have another company called AI surgical guide design company called Atomeca. They will give this presentation. Okay, and also I remind daughter take this the offer from the Tridental. That I think the very good, and also we try to negotiate some lab to make the restoration for our doctor. Okay, thank you so much. Have a good night. Bye.